University of Venice, Italy, and also he had completed his postdoctoral research also from the same. He has working experience as a researcher at University of Minho, Portugal. His research area interests are broadly on the areas of applications of blockchain technology, machine learning, artificial intelligence, and blockchain for cyber security, formal methods for program analysis and verification, programming languages, and also information system security and robotics. Now the session is hand over to Dr. Rajananda sir. Sir, please.
Thank you. Thank you for your introduction. So let me share my screen first. So if you kindly confirm me that if screen is visible.
Yes, sir.
Okay, thank you. Well, so let me start with this session. First of all, thank you, Dr. Kalpana, for inviting me. It's a great opportunity for me to share some information about blockchain components with all the participants. Let me start with basic, and then we'll move towards more information. And feel free to ask any question if you have. Okay, so let's make it more interactive. Well, so I think you have already got idea about blockchain technology in the previous session, or first session of the program. But still, I would like to start with the similar kind of thing. There might be overlap, but it's okay, I think. We already know that how bank and credit cards all the work, right? So in case of bank, we have different stakeholders involved, like customers, bank employees, and a regulatory agency like RBI. On the other side, in case of credit card, we have a lot of different stakeholders involved, like customer, and there will be some issuer bank that will issue credit card to the customers. There will be merchant from where we purchase something, and there will be some associated bank with the merchants, and also there will be Visa or MasterCard network that will handle all this kind of settlement. So what I want to say that, okay, there are so many stakeholders involved in the whole system, and probably we do not trust each other. So in this case, there can be different kind of concern that may arise, and we normally, we have already dealt with those kind of unforeseen situations sometime in our life. So for example, what I can do, I can write a check or I can make online transaction, but there's a high chance that someone can force check or signature, and even when I write some amount in the checkbook, so anyone can temper that field and can modify that amount in the check. Even sometimes I also faced that kind of issue that I requested for money withdrawal from ATM, but ATM has not released money. But at the same time, amount deducted from my account. But although later on that has been solved. In fact, sometimes when we see the bank statement, monthly statement, or yearly statement, we can find some unexpected transactions also. It may be due to your password may be leaked, online banking password may be leaked, or SIM card can be under fraud, or maybe some kind of untrusted bank employees, okay, are there. Who can leak your information, and there are a lot of things that we observe in credit card fraud scenarios, right? If you search, you can find lot of search news, and even in the past also we find there was some news that you receive some OTP, and someone can call you. And can ask for that kind of OTP. If you don't know, if you share that OTP, then money will be deducted from your account. So that can happen, all these things. But who is responsible for that? Of course, bank, right? Bank is maintaining all the kind of transactions in their database, and they are maintaining all this, and they are providing all kinds of services. But there can be some kind of security risk involved, because a lot of third parties involved whom we do not normally trust. So therefore, can we do argument with bank employees? No one will listen you. you know no one will listen you can tell that I have not done these things, but still that has happened in my bank account, but no one will listen you, and that's a very tedious job and very disturbing situations. Even in your daily life, we can find a lot of cases where we are dependent on third party services, right? So for example, if we want to send money from abroad, in fact we have to be dependent on various third party services, and for which they will charge some amount, right? So for example, if I send 1,000 euro from abroad, maybe 5 euro will be given as charge for their services. So here the basic question comes that, okay, it's your money and you are sending your money from your abroad account to your account in India. So then why you are going to dependent on third party, and why you are paying that money, extra service charge to this third party? So it's your money, you are the owner, right? And you have the internet connection, you have the laptop, you just connect your laptop with internet, and you just click on some button, and then money should be transferred, right? Because everything is online. So why we have to be dependent on third party? So because third party is not trusted, number one, and then second one is that that incurs a lot of service charges. In fact, very recently you have also heard about a lot of things about Punjab Maharashtra Cooperative Bank, right? Even though RBI is there, but somehow you can understand that how they try to uh, I mean how RBI cannot find all these things prior to this kind of crisis, right? So many manipulation can be on behalf of the bank that RBI cannot RBI can overlook. Or so it means that because of third party involvement and lot of manipulation can be done by the third party, so it's really risky. I mean, it's your money, you have kept your money in the bank, but and later bank is saying that, okay, you don't get your money, or even RBI can say that, okay, you can get fixed amount of money, not full amount of money. It's your money, but you have lost it. So a lot of things may happen, and that may ruin our life. Even that is another very one kind of scandal that happens in Kolkata also, that that there was a racket. They are selling that dead animal meat to different shops, hotels, and it's very difficult for the shopkeepers or the hotel owners to identify that whether those meats are from dead animals or it's genuine, right? So it's very difficult to trace all these things because there is no transparency, lot of middlemen involved, and that's why you cannot trust middlemen, and middlemen can do all this kind of manipulation. That's why, even though it's written that, okay, this food is being produced by this company, but how can you believe that? You can purchase something, baby food from market, but it's mentioned that, okay, this food is prepared by someone, but expiry date is this. But can you really believe that thing? That can be manipulated, right? That can be tempered. So trust is not there, transparency may not be there, and that's why you cannot trace the whole thing, and you cannot make anyone accountable for that. It's very difficult. So therefore we need some kind of technological solution that will help in all this case, and blockchain is the only solution for that. Until 2008, this was an open question that is it really possible to create a digital form of money, and there will not be any kind of centralized authority. No bank will be there, no credit card company will be there, no third party will be there, no centralized authority will be there. The user will be the owner of their own money, right? So and in 2008, the first white paper was published by Satoshi Nakamoto, but still no one knows that who is actually Satoshi Nakamoto. Actually, someone has published this one, someone has proposed this one with some kind of fake name. But actually, this no one knows about this. Who is actually Satoshi Nakamoto? No one knows it. And the person who has published this white paper, he has also implemented a very small kind of prototype. He has made that prototype publicly available, and in 2009, that using that prototype, first transaction happens, also Bitcoin transaction happens. But after 3 years, suddenly this person disappeared, and no one knows that where this person is. I don't know why he has left from the scene. I don't know. But after 3 years of maintaining this software prototype tool, he has already suddenly left the whole. Uh, and even today, when Bitcoin is so popular and a lot of people are, demand is very high in the market, then many people are coming and saying that they are Satoshi Nakamoto. Still, it's not proved that whether he is actual Satoshi Nakamoto or not. I mean, it's under the judgment or court. So if you look at if you search website, you can find today more than 7,000 cryptocurrencies exist. Bitcoin was the first one that was introduced in 2009, but today more than 70,000, 7,000 cryptocurrencies exist in the market, and Bitcoin, of course, is a popular one, and Ethereum is in the second popular list. So when I started looking at this, blockchain cryptocurrency in 2019, at the beginning in January, that time I searched that what is the market price of Bitcoin, and that time I find that okay, in 2019 beginning, that was January 2019. Yeah, sorry, January 2019. Okay, that was the Bitcoin price. But when I search yesterday, I find this is the price. Even it's varying. Sometimes it's moving towards 60,000, sometimes 45,000, like that. So you can find that this variation depends on demand and supply in the market, right? Supply is fixed. 21 billion Bitcoin is in circulation, but demand may be high. Someone can purchase Bitcoin to purchase. I can purchase Bitcoin from the market, and I can use that Bitcoin to purchase something from some seller. So if that kind of demand increases, so of course that market price also will increase. Now, behind this Bitcoin, the actual technology is called blockchain technology that you already know, and there are a lot of applications of that. It may be IoT security, it may be supply chain, it may be copyright protection, it may be KYC, it may be file sharing. Everywhere, e-governance, e-commerce, everywhere you can find blockchain technology, and it is giving more trust to the system among the stakeholders. It's bringing transparency. Everything is transparent. You can look for everything, whatever you need, depending on the application's objectives. So here I have observed, these are different things. I don't think it is visible to all of you, but let me check if, yes. Different countries are focusing on different sectors using blockchain technologies to provide solutions. For example, in case of e-governance, in case of identification management, in case of payments, in case of insurance, in case of endangered species protection, in case of carbon offsets, enterprise, real estate, shipping, healthcare, supply chain, border control, energy, land registry, computation, advertising, energy, so everywhere, tourism, national security, music, fishing, enterprise, journalism, diamond business, or railways, taxation. So everywhere, this is not the exhaustive list, but you can find more beyond this. Okay, so now let me ask you the question that should I go through this? What is hash? All these things, or if you already know, then I can skip this part. Uh, can I get some response from the participant if you already know,
So
or I
it can
should?
be repeated.
Sorry.
Sir, you can please repeat, sir. You
Sure.
can this from.
Okay. Sure. Well, so now let me start with hash. What is hash function? Hash function is nothing but a mathematical function that should be very efficient. Okay, the computational complexity should not be very high, it should be very efficient. I'll give the input, immediately I can get the output. But you can see from this picture that input can be, input domain can be very, very large. It means that you can have some input of size, very large size. The string, for example, the string can be very large size here. And you apply this hash function, you will get some output here, and the output codomain you can find very, very small, right? So if codomain is small, it means that this is of fixed size. Whatever hash value you get, all are of fixed size. So if I consider 256 bits for the final output, so every output is of 256 bits. It means that how many possible outputs can be here? One output size is 256. So how many possible outputs can be here? Anyone? If I have 4-bit,
64.
yes, in case of 4-bit, it's 2 to the power 4. In case of 256, the total number of output in this codomain is 2 to the power 256. That's fixed. But here, input size is very, very large. And therefore, you can, when I give this input, it can map to here. If I give this input after applying this hash function, I can get it. If this is the input after applying this hash function, I can get this. So from here, it is obvious that since input size domain is very large, number of inputs are very large, more than 2 to the power 256, more than, but output domain is fixed, the number of elements is 2 to the power 256. So of course, it is obvious that at least two of the input after applying hash function can map to same output. Yes or no? For example, I have 10 such elements in this input domain, and I have only 8 elements in this codomain, output domain. So in this case, of course, 10 is going to map to 8 elements. So of course, there will be at least 2 elements which will map to the same element, and that is called collision. So let me give one example, that this is my input. I have taken some word, and the hash function I defined as this one, mod 26. This is the hash function. So what hash function will do? Hash function will take this string and will consider the numerical value of those kind of alphabet and then apply mod 26 after summing up. So finally you get this, and this is nothing but I think O or L something, right? 15. So if you consider, if you start from, so E is 5. So I mean A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. Okay, 15 means O. So therefore, if you give this input, you will get final output O or this value, whatever numerical representation. So this is one example of hash function. So it's called one-way hash function. It means that you can get output. If I give output, can you get input? Is it possible? If I give you O or 15, can you get back to this string? Not possible. It's not possible, right? So let me give you one example here. Here you can see that I have two different inputs. This X input is this one, Y input is this one. And the same hash function I have applied, whatever I defined here, same hash function I have applied here. And in both of the cases also you can find the inputs are different, but output they are same. And this is called collision. As I already told, if I have, since the input domain is large enough compared to the output domain, so at least two elements will map to the same element. So here you can find at least two elements going to map to the same output. This is called collision. And that's why if I give you output, you cannot map to input. Because if I give output 2, you cannot get back the input. So therefore, it's only one-way hash function. It cannot be both the way. I mean, you cannot get the inverse of the hash function. So now, is it possible to remove any collision from this? So can you define any hash function that will not have any kind of collision? Anyone? Not possible, right? Collision must exist because you can see the input domain is large enough compared to the output domain. So collision must exist. You cannot have any situation where there is no collision. Collision must exist, but you have to design the hash function in such a way that you have to reduce the possibility of collision. Okay, practically you can have collision infeasible. I am not saying impossible, infeasible. Okay, so that may be one possibility that you can reduce the number of collisions in practical situation. I mean, it's infeasible, you can say. Okay, so even one very interesting thing is that in case of hash function, if you change even a single character in the input, you can see if you compare these two, here you have V, here you have O. If you have a single character change, the hash function will produce significantly different hash value. So it means that if anyone tries to modify or temper the input data, even if it is minor, then the hashing will capture this kind of modification. So therefore integrity can be checked using hashing also. Okay. Yeah. Okay. So now okay, I have already mentioned is now coming to one very specific kind of data structure that you already know about pointer, you already know about hash pointer, right? I hope you have already come to know about hash pointer. So hash pointer is nothing but pointer along with the hash value of the target data. If this is the target data, so here this data will be at some address. That address is called pointer, but along with the pointer you can also consider the hash of this data, that you can call it hash pointer. And now using that hash pointer you can construct this kind of data structure. It's very similar to linked list, but with minor modification that here you have all these blocks of data, but here what is happening that here not only you are considering the pointer to this data or block, but here also you are considering hash pointer. It means that not only the address of this previous block, but also the hash value of the previous block you are storing here. Similarly, not only the address of the previous block, but also the hash value of the previous block you are considering here. And this way you can construct one data structure. What is the benefit of this one? Can anyone tell me? Why I am going to consider that hash pointer? Not only the pointer, but also hash value of the previous block I am considering here. What benefit it will give us?
Check integrity.
Right. So therefore, what will happen here? Suppose anyone tries to modify this data. So what will happen if someone modifies this data?
Hash value changes.
Right, the hash value will change, and that will make this hash value
There will
invalid.
be a yes.
Invalid. So in that case, what you have to do, if you want to change this as attacker, if you want to change this one, you have to change the hash value here also corresponding to the modification. Okay, if I consider that you have changed it, it's okay. You have changed this hash value. But if you change it, then again what will happen? The whole hash value will be changed. That will make this hash invalid. So again, you have to change the hash value here. If you try to change this hash, so I mean you can understand that whole blockchain will become invalid. If you try to modify anyone, you have to modify all the things after that. So that's why you can call it temper evident log. And here what will happen, once you write something, no one can modify anything, because if one wants to modify anything, then the whole blockchain will become invalid. So once you write something, it becomes permanent. Therefore, what we can, blockchain is historical records of transaction. Here, blocks in a chain. So all the blocks are organized in the form of chain. So that's why blockchain. And if you compare with physical form of ledger that banks managed, maybe 10 years, 15 years ago, for example, if banks managed this kind of physical form of ledger, that you can compare with our blockchain. So for example, every pages of the physical ledger, for example, you still SBI bank issue passbook, right? And that passbook, you can, if you go there, all the transactions will be printed over this passbook, so that you can consider as a physical form of ledger. So here what you can see, that every page will be equivalent to the blocks, because in every page you have all the transactions written. So in every block you have all the transactions written. Now, all these pages somehow, under binding. So therefore, all these blocks are will be linked with each other. In every page, if you look at, you can find some metadata. For example, there can be page number, there can be some kind of title of the page, right? Similarly, in the block, you also will have some metadata. So some metadata means some information about this block. What is the size of this block? What is the hash value of this block? What is the time when the block is being created? All these things, information will be there. Those are metadata. And actual transaction data will be here in the page. Similarly, in the block, you will have actual transactional data. Now, so this is just blockchain. It seems very simple thing, that this is the form of in the form of hash chain, and you can put details there. Now we are moving towards, that from centralized to decentralized or distributed context. So in centralized, what happens, that all the users actually interact with a centralized server, and centralized servers will provide all the services. But the problem here is the centralized servers will be controlled by someone, some specific person or organization, right? The organization will control it. So it's very, that's why it's centralized. And if you do not trust that person, the organization who is controlling this server, then of course you will afraid of using these services, because there is a high chance that that person or organization can manipulate your information. If you interact with them, that will be risky. And even the more thing is that, the reliability. I mean, this server can fail at any point of time, and then probably for a long time the service won't be available with all of you. But later, what happens, that we moved towards the decentralization, that no, the server cannot be controlled by single person or organization, or even we can say that, okay, if I do not take into consider that organization or person, what we can consider, that okay, server is taking all the decision. The better term will be used, that the centralized server was, deciding everything alone. But here, when I move towards the decentralization, there are so many servers distributed all over the world, and the local users interacting with the local server. For example, in case of Facebook, you can find that all the servers are in all the countries, and all the people of this country will interact with the local server. If somehow this local server not working, for example, in India, if this server is not working, then Indians can get service from the neighbor server. For example, maybe the server in China. It may happen. Therefore, as end user, even though there is a failure of one server, we cannot realize that there is a failure. So it improves the reliability, right? And here, the decision, some kind of decision should be taken not by one, but by all the servers. That is the decentralization, right? So we are not, one person will not do all these things, one server will not do all the things, multiple servers together will take decision. Decentralization and improving reliability, and also, even though to some extent trust also will be increased. Okay, no, now the problem here is that when we talk about Google Drive, or we talk about Facebook, all the servers controlled by the same organization. So even though the task is being decentralized, but the overall control will be with some third party organization. And if we do not believe that organization, so of course there will be a trust issue, and then probably we will be afraid of using those kind of things. You know that the privacy issue, data privacy issue happened in case of Facebook also. We observed, we experienced those kind of things. So therefore, can we move to some kind of scenario where nothing will be controlled by no one? Everyone will be equal. So therefore, we are moving to a settings where all will be acting as the similar kind of, there is no difference between server and client. All are equally treated. I can act as client. I can get some service from you. Sometimes I can also give service to you, similar to in your case also. And the very relevant example is our today's internet. Okay, so therefore, what we are trying to do, we are moving towards distributed, and if it is distributed, so of course it will be decentralized. That kind of settings, and therefore today we are moving towards a peer-to-peer network, and Bitcoin is based on the, all this, blockchain networks are peer-to-peer, distributed peer-to-peer network, and Bitcoin network is running on using TCP port, these things, and the topology is random. Anyone can join anytime, anyone can leave anytime. So it's completely public, and all nodes are equal. So since anyone can join at any time, anyone can leave anytime, so this network is completely public, and that's why Bitcoin is called public network. How suppose you want to join the Bitcoin network. I am taking the one case study that you are going to join Bitcoin network. What you have to do, you have to use your laptop, you have to connect with internet, you have to install the Bitcoin wallet software, and then there will be some button or something through which you have to connect with the neighbor nodes. For example, here you want to join the Bitcoin network, so you can interact with the nearby node, and you can ask the nearby node that I want to join this network. Please give me the address of your neighbors. So 5, the address of 5 is 1 and 7. So 5 will return 1 and 7. So 5 will return 1 and 7, and then 8 will interact with 1 as well as 7. So this way, after multiple iteration, 8 will be connected with few of the nodes in the network. It depends that how many nodes this 8 node want to make neighbor. So this way, the node can be connected with the Bitcoin network. So now, once this kind of network is formed, what happens in general that this blockchain copy that I already mentioned before, right? This is the blockchain copy. This blockchain copy this blockchain copy will be with every participant in the network. So for example, in this class, if we have 50 participants, so if we all 50 participants create one peer-to-peer network, blockchain network, then in that case, if we are going to use blockchain technology, so the blockchain copy, that chain of blocks where all the transactions will be stored, it will be with all the participants. Then what will happen in case of any kind of new information to be added? Suppose this person wants to add a new block of information here. So when new block of information will be added in this blockchain, the local copy of the user, the similar kind of addition should also happen with other copies with other participants also, right? Otherwise, the information will not be consistent across the network. So what will happen if this is me? If I want to add some new block with new information to this blockchain, I cannot add directly. What I have to do, I have to pass through some consensus mechanism, and then if all agree, then only this block can be added to the blockchain copy by everyone. Like this, 4 can be added by everyone to their corresponding local copies. So consensus mechanism is there. This is a very simple example that how this kind of this is the overall thing that the main challenges consensus algorithm, so this is the primary thing. But on top of that, also this technology uses cryptographic primitives. So I would say important thing is there. One is that the data structure where the actual transactions will be stored. This is one part that I have already told. They are using hash pointer and making a chain of blocks. Second one is that distributed computing, that everyone will maintain the blockchain copy locally, but to maintain the consistency of information among all the copies of the blockchain, a consensus mechanism to be followed. They have to agree on the common thing. This is the second one. And third one, they are using some cryptographic primitives. Okay, so these three things are crucial in this case. Now, this is one example that suppose initially there are four people in the network and they are maintaining blockchain copy, and blockchain copy is having suppose one block, simple one block, and in the one block, I mean, it's just for illustrative purpose. Actually, the structure is different. So in this case, suppose this rupees is there with Alice. Now Alice wants to make a transaction with Bob, 50 rupees. So you can find that what Alice has to do, Alice has to broadcast. So what Alice will do, Alice will first create one new transaction that I want to. So there is wallet software with Alice. The wallet software will help Alice to create this transaction. So Alice has to use the wallet software, and Alice has to mention that how much amount, how much money he is going to transfer to whom, and then she has to click the button, and then this transaction will be created. So once this transaction has been created by Alice, so what is the next task? That this transaction will be broadcasted in the network, and through consensus algorithm, if everyone finds that this transaction is valid, there is no problem, so then everyone will add this new block with new transaction to their blockchain, local blockchain copy. So this will happen through consensus. Next, suppose Bob wants to transfer 30 rupees to Eve. There is no issue. Bob has now 50 rupees because Alice has already transferred rupees to Bob. So there is no issue. Bob can transfer 30 and Bob will create this transaction. Bob will broadcast this transaction to everyone, and through consensus mechanism, this new information will be added to the blockchain copy. Suppose now Alice is trying to make this kind of transaction. Can anyone tell me whether this transaction, if Alice creates this transaction and broadcasts this transaction in the network, and if you are part of this network, do you agree on this transaction? Very simple. Can anyone tell me? If you are part of this network, suppose you are here, and since Alice has broadcasted this one into the network, you also receive this transaction. So do you really accept this one, agree with this transaction?
No, sir.
Why not?
Because amount is 30 rupees, but the transaction amount is 80 rupees, sir.
Right. Here you can find Alice has already transferred 50 rupees to Bob, and so Alice has only 50 rupees remaining. So how Alice can transfer 80 rupees? She doesn't have enough amount. So this transaction is not valid. So the network, all the nodes will not agree on that, and therefore no one will accept this one, and this transaction will not take place in the blockchain. So here you can find that because of this decentralization, because everyone participating in the network are taking some kind of decision, are taking part of the decision making process. So therefore, although some attacker can try to do some kind of malicious activities, but overall network will not accept it, because everyone is participating in the consensus mechanism. Okay. Even if I am friend of Alice, I can accept it, but it doesn't matter. It will, the wrong information can be in my blockchain copy only. others will not accept. So majority of the people will not accept this, and that's the beauty of this blockchain technology. And this brings, even though Bob, they do not trust each other, but the technology itself brings the trust. And so I do not trust Bob, I do not trust Alice, but I trust this technology because it is bringing the it is bringing transparency, and everything will be in my control. Okay, so therefore, repeating it, that the logical components of blockchain, that shared ledger, that how you store these transactions, what would be the structure, data structure of this transactional, cryptocurrency transactions or other kind of transactions. So, of course, blockchain, chain of blocks connected through hash pointer. The network will be formed in the form of peer-to-peer distributed network, and your computer will act as a node. Others' computer also will act as node. So there could be, there are some client softwares. There are some softwares that if you install on your machine, then your machine will act as a node in the blockchain network. For example, in case of Ethereum, Geth, Geth, Geth is one such software. You can try with Geth. You can download, you can install Geth, and through this software, you can connect with the Ethereum mainnet where actual Ether transaction is happening. Right. So there are some softwares that if you install, you can create, your machine can act as a node in the blockchain network. Regarding this new information, new transactions, addition or maintaining the consistency among all these blockchain copies, ensuring that no bad information is being put into. I mean, especially I can mention the term double spending. So what I can try to do, that I have the money and in the digital form, because there is no physical form of money when I move to cryptocurrency context. So I have the digital form of money. So I can try to use the same money for two different purposes. So I can send the money to my friend, as well as I can send the money to purchase something from some buyer. From some merchant or seller. So in this case, this kind of things called double spend attack, and this is very common in this context. And you have to design your consensus algorithm in such a way that double spend attack should not take place. People will try, but your consensus algorithm should be something that it should prevent that kind of double spend attack, and only the genuine transactions will be considered, will be added into the blockchain. And another thing that I would like to highlight here, that virtual machine. So normally when your machine is acting as a node in a blockchain network, so when I look at only Bitcoin, it has very simple kind of language, Bitcoin scripting language, but it does not support application development, decentralized application development. But when I Ethereum will allow to develop different kinds of decentralized applications that you can use in case of land registry, in case of supply chain, in case of e-governance, in case of e-commerce, in case of car sharing. So as I already told, blockchain technology has a lot of applications. So first, Ethereum has introduced this concept that blockchain not only being used for cryptocurrency transaction, but also we can use blockchain technology to develop the applications, and we can solve many real life problems. That gives the power to blockchain technology. So therefore you can find today blockchain has a lot of applications, and there what they have done, they have introduced a language, programming language, and there is a notion of execution of those programs. You can write your program, those called smart contract. You can deploy your smart contract, you can keep your smart contract in the blockchain, and you can execute, because blockchain copy will be with you. You can execute those smart contracts. So here when blockchain is being, used to develop the decentralized application, it means that blockchain supports some kind of programming language through using which you can write small code programs. I mean smart contract. Since those programs should be executed on the nodes in the network, so every node can execute those programs. So for execution, you need some kind of runtime environment, and those runtime environment will be provided by the virtual machine. So that I'll also talk about later. So these are the logical components. So therefore, I can ask few questions after having this information. Who will maintain the ledger of transactions in a blockchain network? You, me,
Everyone
everyone,
in the
all participants.
all
Oh,
participants.
right. So how okay, we can maintain, all participants will maintain the blockchain ledger of transactions with blockchain. But how? How to maintain? How to add information? Any answer?
After authentication?
Yes. So all this authentication, mining process that I will highlight. So consensus overall, right? So consensus should be there through which we can maintain that. Who determines the validity of transactions? So for example, as I told in the previous example, that Alice has sent the transaction and broadcast in the network. Here, as I told, this transaction is being broadcasted by Alice to everyone. Now, who will check that whether this transaction is valid or not valid?
The
I
miner?
mean, only miners. Who determines
The
the validity
nodes?
of transaction? Sorry.
Nodes and the participants?
All participants, any participant can check the validity. Even though you are not miner, even though I am not miner, but I can also check the validity of transaction broadcasted by XYZ. Okay. So all participants can check the validity. It's not mandatory. You cannot, because there is no centralized authority to enforce you that no, you have to. You are free. If you want, you can verify. If you don't want, you ignore verification, right? But you can verify whatever transactions broadcasted by everyone. I mean, when you want to transfer some money to someone, you have to create the transaction and you have to broadcast it in the network. Similarly, XYZ is creating some transaction to transfer money to his friend. So XYZ also will create the transaction, will broadcast in the network. So being a participant in the network, I can receive all such transactions issued by all the people in the network. So I can verify the transactions. If I find that some transactions are correct, valid, I will forward those valid transactions to my neighbors. If I find that some transactions not valid, I will disregard them. I do not forward it. Okay, so how one can verify? How one can verify? I mean, you issued one transaction, you broadcasted it, and that's why I have received your transaction. So in your transaction, you have mentioned that you are going to transfer 50 rupees to your friend. How can I verify that your transaction is valid?
Through the consensus algorithm?
No. Only validity checking. I can personally check it. I don't have to be dependent on others. Because you can find here. Because as I told, this is me, suppose, and I have the whole blockchain copies. I mean copy. So every transaction, history of the transactions I have, right? So suppose this is you. You want to transfer some money to your friend. So you have created one transaction saying that I want to transfer this money to my friend, 5 Bitcoin, suppose. And you have broadcasted this transaction to everyone. So when I receive your transaction, I find that, okay, you are going to transfer 5 Bitcoin to your friend. So how can I check that whether this transaction is valid or not? Because I can check the transactional history, and accordingly I can decide whether this new transaction is valid or not valid, right? Yes or no?
Yes, sir.
As like here, it's happening. You see, when you receive this transaction, if we'll receive this transaction, if you can check, okay, Alice has only 50 rupees. Alice has already sent this money. So this transaction is not valid, right? This kind of validity checking can be done. But of course, you can find that this cannot be done manually. Na? There should be some kind of automation. I mean, there should be some software. I mean, your wallet software even can do it. I will click on the button that verify, and then verification automatically will be done because everything is automated, right? So some algorithm is there to verify it, and that algorithm will use some kind of language, and that's called Bitcoin scripting language. If you search, you can find Bitcoin scripting language. So this Bitcoin scripting language is very it is very expressive enough. I mean, it's not very similar to your C programming language or Java programming language. No, it cannot do many things. It does not have any recursion. It does not have any loop. It has very simple kind of opcodes, and using that scripting language, you can. I mean, when you create the transaction, you have to mention something in this scripting language. So, for example, if I want to transfer my money to my friend, I have the wallet software. Wallet software will create this transaction, right, on behalf of me. That I want to transfer to my friend. So, when the wallet software will create the transaction, in this transaction, some kind of script, some field will be there written in this scripting language. So then any participant can verify by executing that script part. Okay, and final one, that who will create new Bitcoin, and that will happen in case of mining process. When mining means adding a new block to the blockchain, right? A lot of things. So through that process, new Bitcoin will be created. Okay, let me. Yes.
Regarding the reward for mining. So the market cap of the Bitcoin will be determined by the founders, right?
Okay. Yes. So market cap.
So that
So
is
you know that.
restricted to that is restricted to a value. And if miners are going to get rewarded, that reward Bitcoin should come from that already existing reserve, right?
So when Bitcoin was introduced, that time it was decided that 21 million Bitcoin will be made available, right?
Yes.
And then that Bitcoin, how that could be distributed among the participants, among the users. So who will do the mining process? They will get some reward, and that is the new Bitcoin given to him out of 21 million. So that total amount of Bitcoin is fixed. And now this Bitcoin is being given to all the participants, all the miners, in the form of reward. And till the date, I think 19 millions already given to the miners, and remaining Bitcoins will be given to the miners in the subsequent years. And after 2040, there will be no amount available to give as a reward to the miners. So this is the thing. So I mean, have you got your answer, or I think there is some?
No, it's still confusing.
Yeah. Yes. Can you? Yeah. What you want to know? Can you tell me?
I mean, you were mentioning about the 21 million, right?
21 million. Yes. Right.
Yeah, that 21 million it's already frozen. That limit is frozen.
Yes.
And maybe that 21 million would have been distributed to all the participants, whoever has bought it.
No, bought it. This is not a good thing. I mean, from whom you will buy it? It's not bought. From whom you will buy it, because there is no centralized authority, right?
Yes. So it's a peer-to-peer. I act as a
Yes.
one peer and I buy it from another peer. So but
No,
I
no, no,
spend
no,
some
no.
money to
How?
buy it.
No, no, no. How can you get it from another peer? Because how another peer will get it? If you buy
He
something
is
from
already,
another peer, but how another peer will get it?
yeah, because he is already holding it.
But how he is holding it? How did he get it? That is the question. So how new Bitcoin is being given to a node? That is my question.
Was that
Once,
from the founder?
no, there is no founder event. You know, founder has also no control on this blockchain Bitcoin network. Founder is also the same as like me. He also has one node. I have also have one node. There is no centralized authority. There is no control. I mean, they are all same. Satoshi Nakamoto also same as like me, as like you. Okay.
But they have the limit on the amount of Bitcoin which will be in circulation, right?
Yes. So when first time it was introduced, that time it was fixed, and that was agreed by the initial group of members, and that is going on.
Sir,
And that time, yes.
good afternoon, sir. Whether why it is particularly 21 million? It can be 50 million. It can be 10 million.
Okay, no one can answer this one because at that time, you know that what was there in mind. There may be some mathematics. There may be some kind of calculation they have followed. Maybe still not clear. I mean, I have searched also, but it's not available. That why they have chosen 21 million. It may be that time one Bitcoin is equal to. They tried to make it equal to one USD, maybe, but not sure. Okay, people
Sir,
try to infer something.
once if every Bitcoin is mined, what is the
Mhm.
purpose of miner? What will be there?
Okay, so let me go through the other slides. And this question will be okay. Okay, let me continue, and then maybe finally we take other questions. If so, let me talk about that how blockchain works. I will take Bitcoin as a case study, and I'll tell you that how whole blockchain technology works. So first, you have your a laptop, and you have installed your Bitcoin wallet, for example, and you want to transfer some money to your friend, maybe 5 Bitcoin. What you do, you ask your wallet, the wallet software will help you to create a transaction. In that transaction, you have to mention that you have to mention from where you get this money. I mean, there are some previous transaction through which you got money, right? So you have to mention in your transaction from where you get money, which transaction, previous transaction you get money from, to whom you are sending the money, and how much amount. Those things you have to mention in the transaction, and something you have to mention in the Bitcoin scripting language also, and that will help other people to verify whether the transaction is correct or not. So anyway, just assume that okay, some transaction. I mean, what you want to do, the transaction will be created by the wallet software, and it will be broadcasted in the network. So when it is broadcasted in the network, every participant can verify whether this transaction is valid or not valid. If the transaction is valid, somehow using Bitcoin scripting language and its execution, I have some slides on that. So after validation is done, then what it will, okay, here you can find every it is broadcasted and everyone is verifying whether the transaction is correct, and if it is correct, they are forwarding it to their neighbor. If it is not correct, they are not forwarding. Okay, so somehow it's flooding in the network. As I already told, every transaction will have some input and will have some output. For example, this is a transaction. Suppose XYZ has sent 5 Bitcoin to me. So here in the output, XYZ has to mention that give 5 Bitcoin to Raju Holder. Here it will be mentioned. And now it means that 5 Bitcoin I have. So therefore now I can create a new transaction. This transaction already in the blockchain, right? Where it is mentioned that give 5 Bitcoin to Raju Holder, and that has been sent by XYZ. Now this is a new Bitcoin, the new transaction that I can create, And in the new transaction, I can tell that, okay, that please refer to my 5 Bitcoin here. This is my input. And in the output, you can mention that, okay, I want to transfer this 5 Bitcoin to my friend. So new transaction I can create. So this is the high level structure of this transaction, that there will be input field, there will be output field. It's like a checkbook. I mean, today also you write something to whom you are sending, right? Which account you are referring to. I mean, from where you are getting this money, and you have to provide your signature. Remember that you have to provide your signature in your transaction also when you are creating it. This is, I don't know if it is visible. This is the structure of this transaction, a very low level structure. So this is the transaction that I have created. Here I have mentioned that please refer to the previous transaction hash from where I am getting money. And provide, here I have to give my signature, digital signature. And in the output section, I have to mention, please transfer this 5 Bitcoin or 10 Bitcoin to my friend. So here it will be the friend address. So how the address will be mentioned, how address will be created in the Bitcoin? Can anyone know it? How I can tell that, okay, send this money to my friend? How I can recognize my friend? With his name? Of course, no, because the real identity will be revealed. This is nothing but
hash function we can.
yes, this is nothing but hash value, but hash of what? Hash of the public key of my friend. You know that public key, private, asymmetric key cryptography, anyone can generate its own private key public key pair. So this is nothing but, if I want to send the money to my friend, it's nothing but hash of the public key of my friend. Okay, so I have to mention that, okay, I get money from this previous transaction, this is my signature, and please send this amount of money to my friend. And I have to mention some other things also from the Bitcoin scripting language. So this is the Bitcoin scripting language. So here you can find, so input output, yeah, I'm sending, and this is my signature. And then you can find, I can just quickly highlight the high level thing, that, okay, this is the transaction which is already in the blockchain, and this is the new transaction that I have created. So suppose I am Bob. So Alice has already sent some Bitcoin to me, and this is already in the blockchain. So I have already that amount. So after 1 year, maybe I am just, sending that amount to my friend Carol. So this is the new transaction that I have created. So when this new transaction I have created, I have to transfer, broadcast it in the network. So anyone in the network can verify whether this transaction is correct or not correct. So what they have to do, if they want to check that whether this transaction is correct or not correct, what they have to do, they have to check this field, input field. Okay, it is referring to the previous, this transaction. Okay, from this transaction, take this whole part indicated as 2. So this whole sequence should be considered, and then the signature of Bob here, this should be considered. So 1 and 2 will be considered by anyone, who is going to verify it. Suppose you are going to verify it. So you take this 1, 2, you take this one, that is 1, and you put them in sequence, and you just execute them. This is the execution. I'm not going to tell about all these things in detail. So after this execution, you find everything is right. So your software automatically will check this, that this transaction is valid. Is there any questions up to this point? Please feel free to. Okay, so what I tried to say, that there is some, that this is the transaction which is already there in the blockchain, where some money is being given to me, Bob. So of course that money is my money, so I can now transfer that money to my friend. So I will create the transaction and I will broadcast in the network. So anyone in the network can verify it, because they have the whole blockchain. So this transaction also in the blockchain copy, and this is the new transaction they have received. So what they have they can do, they can extract this information, put them in sequence and execute it somehow. Stack based execution. And finally they observe that it's fine. So this way all these transactions will be checked by every participant, or maybe some participant in the network. And finally there will be some specific nodes which we call miner. I can also act as miner, you can also act as miner. There is no strict rule that anyone can act as miner, but there is certain condition that okay, what miner will do, miner will capture all these transactions and will create a new block. So if I make the transaction, I broadcast it, the whole network can check the validity. Similarly, other nodes can also issue transaction and broadcast them. So there are special kind of nodes who can consider a set of transactions broadcasted in the network in recent times, and they can create a block. So this is the structure of the block. So all transactions miner can consider, that will be considered in the form of Marklet tree. So Marklet tree is a specific kind of data structure, and the root of the tree will be put here. So this is the part called metadata. This is the part called data. As I already told, every block will have two things, right? Metadata and actual transactional data. So this is the metadata and this is the transactional data. So once this block is being created by the miner, then after creation, miner has to prove something. What miner has to prove? Then miner has to do some proof of work. What is this? In this case, the block that has been created by miner, the miner that has been created by miner, what miner will do? Miner will apply the hash function. And after applying the hash function, whatever hash value will be obtained, then there must be a required number of zeros at the beginning. For example, if it is told that if you are acting as miner, you can create a block by considering a number of transactions, it's okay. After that, you have to apply the hash function, you will get the hash value. But how many zeros are there at the beginning of the hash value that you have obtained? Is it 30? Suppose 30 is the value. Is it 30 number of zeros? Then you are successful. If not 30 zeros, then you are fail. You fail. For example, here, this is the input. You apply the hash function and you get the output. And here you can find that whatever hash value you get, 3 zeros are there at the beginning. So you are lucky enough that you get 3 zeros at the beginning. So I mean, how many zeros should be there at the beginning of the hash function? That is already defined by the network. And every 2 weeks, this value may change. Every 2 weeks. This is called difficulty level. So if you increase the number of zeros, the difficulty level will decrease. If you decrease the number of zeros, the difficulty level will increase. For example, here, if I say that whatever hash value you get, it should have only 3 zeros. This is number 1. And number 2, whatever hash you get, it should have, oh sorry, I made a mistake. So here, if the number of zeros reduced, then difficulty level will also reduced. So if I say that you have to get only 2 zeros, it means that 8 possibilities. If I say that you have to get 3 zeros at the beginning, only 4 possibilities you have. If I say that only 2 zeros should be there at the beginning, you have 8 possibilities here, right? Which one is more difficult to obtain? 2 zeros or 3 zeros? Suppose this is the block you have created as a miner, and you apply the hash function, you get some hash value, and in the hash value you get 2 zeros, and someone else got 3 zeros. Which one is more difficult in terms of maybe probability? Which one?
3-0.
3 zeros is more probable or 2 zeros is more probable to get?
To get will be 2 zeros.
Yeah, 2 zeros is more probable to get, right? So if you apply, this is high chance that you will get 2 zeros, but it is less chance that you will get 3 zeros because you have less options. For 2 zeros, you have more options. So therefore, having 2 zeros is less difficult. Having 3 zeros is more difficult. So therefore, how many number of zeros you have to obtain, the network will decide every 2 weeks. Okay, so if you get enough number of required number of zeros at the beginning, you are successful. Once you are successful, so for example here you can find, so if suppose you are not successful, you do not get required number of zeros, so what you can do, you can change the nonce value. There is one field in the block. So if I go back here, nonce, this is in your hand. So what you can do, you can change the nonce value. If you change the nonce value in the block, then your hash value also will change. Then you can try again and again changing the nonce value. For example, here you consider one nonce value, you get wrong hash value. I mean, hash value should have required number of zeros at the beginning, right? And you get wrong number of hash values or less number of hash values. So you change your nonce and you keep trying. Even if you do not succeed, what you can do, these are the transactions that you have considered in the form of Merkle tree in your block. So in this case, there is one special kind of transaction that you have to create. Let me tell you one thing again. So these are the transactions that everyone or the participants in the network have created, right? And as miner, you are considering them in the block. So all the participants broadcasted all these transactions and you have considered all the transactions to create a new block as a miner. But there is one additional transaction that you can add on your side. And here you have to mention, this is called coin-based transaction. And here you can mention the reward, that if you succeed, you get this amount as the reward. So this is called coin-based transaction. Here you have to mention the amount that you will get as the reward if you succeed. So now in the coin-based transaction, there can be some field which you can also modify. So you can modify those fields and you can also try again and again. And finally, you are successful. Then you add this block to your blockchain copy because you have your own blockchain copy on your own machine, right? You add this block to your own blockchain. Okay, so after success, you add this block to your own blockchain. I mean, miner will add the block to his own blockchain, and miner also will broadcast this new block in the network, saying that, okay, I am acting as miner. I have got this new block. I am successful in doing proof of work. Now, please, you consider this block to your blockchain copy. So all the participant will receive this one because miner is broadcasting. So all participant will receive this new block, and all participant again will verify whether this miner has done or created this new block according to protocol correctly or not correctly. And if this block is being created correctly, then all the participants in the network, they will also consider this new block to their blockchain copies. And this way you can find this new block will be added to all the copies in the network, and the information will be up to date. So this is the whole working principle. So if anyone has any doubt, feel free to ask me now. But of course, you know that you will get, subsequent, there are so many sessions, and you will get more details about all these individual activities.
Sir, can any participant refuse to give his consent despite all the verification that has been done?
Yes. Participants can also act as, attacker, and they can do something bad thing. They can ignore doing verification, they can consider bad transactions, it's okay. But only that his blockchain copy will be affected, not others' blockchain copy. Because everyone will have their own blockchain copies, right?
Yes, sir. So then what will happen to the new block? Will it be added to the chain or not?
Yes,
Because,
that will be added to the chain of other participants, because other participants have their own blockchain copies, right? So other participants blockchain will have this new block added, but who is acting as the dishonest person or the attacker, his blockchain copy can be affected.
so, sir, the consensus will be broken and
No. Dishonest. So consensus does not say about dishonest persons. The consensus criteria tells about only honest person. So wrong thing should not be there in the honest person's blockchain. That is the criteria.
okay, sir.
If I am acting as honest and I am participating in the consensus, my copy should be the perfect copy. If you are acting as attacker and you are not participating in the consensus in according to the protocol or some honest way, so it's about you can have wrong information, you can have bad blockchain copies, you can have wrong transaction. It's the problem for you. I am not dealing with you, but my copy is perfect.
So despite being honest, some error might occur on my behalf.
It depends
And
on the no, who is actually writing, not error. I mean, so if miner is doing right thing, right? If miner is doing right thing and I find that miner has done it right, then I can consider that block to my blockchain copy. Then my blockchain copy also will be the right one. So here, who is the actual writer? Miner is the actual writer. You are just adding them, but actual block creation is being done by miner. So it is assumed that more than 50% power should be with honest miner.
okay, sir.
If more than 50% power should be with honest miner, then your network is safe. But if more than 50% power will be in the hand of dishonest miner, then it is quite risky. And here power means computation power. Because why computation power? Because I told that actual proof of this mining process is being done by changing the nonce value and doing the hash computation again and again to get the required number of zeros. So this requires lot of computation, and that's why computation power I am talking about. So more than 50% computation power, hash computation power should be with honest miner. Okay, am I
Yes, sir.
have you got? Okay. So now the problem here in this consensus algorithm, it's called proof of work, and but the problem is that a lot of computation required, because as I told, you have to change the nonce value, you have to compute hash again and again, you have to find the correct hash. So it's very energy energy consumption is very high, and even it can power the entire country like Switzerland, Ireland, all these small countries. So therefore, this is not the perfect solution. I mean, we should look for some alternative consensus algorithms like proof of stake, practical Byzantine fault tolerant, Raft. So these are various alternative consensus algorithms that other blockchain platforms use. So if you must have heard about Hyperledger using this PBFT. Someone is using Raft. I cannot recall it now. Ethereum initially started with proof of work, but now they are transferring to their consensus algorithm to proof of stake because of this energy consumption issue. Anyway, so this is the overall idea that how Bitcoin blockchain works. So let me summarize that. First, if you want to participate, you join the network, and if you join the network, all other participants creating transactions, broadcasting it, so of course you will listen the transaction. So when you listen some transaction, you can check the validity of those transactions using Bitcoin scripting language. What miner will do, miner will also listen the transactions and accumulate those transactions will create the block. And after creating the block, they will do the proof of work. I mean, they will choose the correct nonce to get the correct hash value having required number of zeros. So this is the mining process. After mining is successful, then what miner will do? Miner will broadcast this new block containing a set of transactions in the network. And when the new block will be broadcasted in the network, being participant, you will also receive the new block, and then you also check whether this new block is being created correctly with the miner or not, by the miner or not. If yes, so you just add the new block and you just accept the new block. And the miner who is actually doing all this proof of work, as I already told, a new transaction will be added by himself or herself. So in this new transaction, the miner can mention that give myself this reward, and this reward amount is very high. Initially, it was 50 50 Bitcoin in 2009. After 4 years, it becomes 25. After 4 years, it becomes 12.5, and now it is 6.75. So from this year it starts 6.75 Bitcoin, and one Bitcoin is equal to, you can understand that, 60,000 USD. So if you can if you can be successful in mining process just for once, even you will be rich enough. But of course you need lot of computation power. That's sometimes not possible. Okay, so overall, very interesting thing is that that when you find that health of the Bitcoin ecosystem, the ecosystem is very large. I mean, lot of millions people connected in the Bitcoin network. So of course, lot of people all over the world connected there. So you can expect that majority of them will be honest. If you have very small number of people, they can do some kind of mal activities together. But if ecosystem is very high, you can expect that there must be some honest people in the so the control, the mining control, the computation power will be in the hand of honest people. More than 50% will be in the honest people. So if if the ecosystem is very high, of course your blockchain will be very secure enough, your Bitcoin blockchain could be secure enough. And if it is secure enough, then of course the value of the currency market price will automatically will increase. If the market price increases, then automatically more people will join. And this is circular in nature.
So, sir, so building another type of coin like a Bitcoin or like a government coin will be a difficult, right?
No,
It
no,
depends
no.
upon the mining ecosystem, right? If it is not
No, it's not. No, building a new cryptocurrency is not difficult. You can create your own blockchain platform and you can create your own, cryptocurrency.
yeah, that thing, okay, sir, like running like an universal currency, like global currency, because like Bitcoin has a small market
Okay,
cap as
okay,
well as
yeah,
more minus, right? So
okay.
that 51% attack on
Of course,
beating them in this one.
I mean, competing with the Bitcoin or Ethereum, it would be quite challenge, difficult at this
Okay,
point.
okay.
But at small scale, you can introduce and you can participate in the market. You can
Yeah,
participate in the market,
yes,
and
yes.
automatically the ecosystem will build. And I know that very soon, recently Polygon, you can go for Polygon, you can find
Yeah,
they
yeah.
have introduced their own cryptocurrency. You can find Matrix, they are introducing their new blockchain platform, and they are also participating in the market, and they are going to be popular day by day.
Yes, like if like those has its own protocols, right?
Yes,
But
yes, yes.
Bitcoin doesn't has its own protocol. It works on a decentralized currency. But if any government, for example, if it is SEC or America or an Indian government is planning to build on a new coin, like
Mm-hmm.
like if they are building it,
Mm-hmm.
uh, like competing with Bitcoin will be more difficult, right? Because
No. It depends. You know that they are not going to make it. For example, India will be going to, introducing their own cryptocurrency, right? Very soon.
yes,
But
sir.
but
We should.
but at the same, of course, competing would be very difficult if both are open to the people. But
Okay.
maybe some kind of rules and regulation will be introduced so that Indians can be more, Indians can be more attracted towards the government cryptocurrency.
Okay,
Some rules
okay.
regulation can be imposed.
There will be a rules and regulation for that,
Of
so
course,
that repair
of
should
course,
continue.
of course. But if Indian government introduces this and tries to make it open to the world, then it will be very difficult for them to get it accepted by the people. Why? Because there is centralized authority, and the centralized authority is Indian government.
Government. Okay.
That people will not accept.
Okay.
But
Okay.
with rules regulation, government can do something.
But like if adopting Bitcoin as an like global currency, it will be there will be more problem, right? If it is like India accepting Bitcoin as a global currency means,
Yeah, it has been already accepted by many countries, right?
yeah, yeah,
So
yeah.
it's already global currency.
Yeah, but like because like some current like El Salvador was accepting because they didn't have their own currency. The reason was they accepting is they are dependent on US dollars, so that they
Mhm.
didn't have their global currency or their native currency. But India has its own native currency as rupee, right?
Right. You're right.
So if it is like building a new system like this will be more difficult to for government, right?
You are saying that government is going to, if government introduces this kind of open blockchain, right? Open
Yeah, yeah.
cryptocurrency.
Decentralized cryptocurrency.
So no, it will not happen.
Okay,
For
okay.
example, you know that Facebook introduced Libra, but it doesn't work because of
Yes, yes.
centralization.
Yeah, yes, yes, yes.
Right. Oh, yeah. So now, okay, let me proceed. Okay. So now, these are the design goals of cryptocurrencies that we have to ensure that transfer will be secured enough and cannot be copied. Cryptocurrency, I mean, one Bitcoin cannot be copied, and same Bitcoin cannot be reused. Anonymity should be preserved because, as I already told, real identity cannot be used. Only hash of the public key can be used. So using hash of the public key, you cannot infer who is the actual person. So anonymity can somehow be preserved. Um, Even if you are not online, you are offline. But even I can make the transaction. Recipient can be offline, doesn't matter. But I can make the transaction. Miner will consider that transaction. Will add it in the blockchain. It doesn't matter that whether the recipient is online. Can be transferred to others. So of course, if I cannot transfer, then no cryptocurrency will work. Can be subdivided. That I have 5 Bitcoins. I can divide it into two. I can send 3 Bitcoins to my friend. 2 Bitcoins to other. And double spending attack should not happen. Okay, and another thing that I would like to tell you, that whatever transaction, so here as miner, I am considering all the transactions. So in the transactions, these transactions created by others, right? So in those transactions, you can find that some input and output fields will be there, right? In this transaction, the transaction should mention that, okay, this is the input from where I get money. This is the output to whom I am sending money. And if there is a small difference, for example, I get 5 Bitcoin, input is 5 Bitcoin and output is 3 Bitcoin. I mean, 5 Bitcoin they got in this transaction and 3 Bitcoin is being sent to the friend. So this difference, that 2 Bitcoin is the difference, and that will become transaction fee, and this transaction fee will go to the miner also. So miner not only will get the will not only get the rewards, I mean, that is the by default 6.75 at this point, but miner also will get, 6.75, no, 6.25, sorry, 6.25, half of 12.5, 6.25 reward by default they will get. But in addition, whatever transactions miner considering in the block, if in those transactions some amount is given as the tip, those also will be the miner's amount. Okay, so I have, I think, 30 minutes. Should I continue, or Dr. Kalpana?
Yes, sir. Till 1:30 you have time.
Okay, sure. Okay, so now I have talked about, blockchain, sorry, Bitcoin cryptocurrency at very high level. Of course, the detail will be, taught in the subsequent sessions. But as I already told, in Bitcoin, only a scripting language, Bitcoin scripting language is being introduced that helps only to check the validity of the transactions. Nothing else. You cannot develop any application. But in 2014, Vitalik Buterin first introduced Ethereum that enables one to develop applications, and that brings a lot of power to the blockchain technology. And after that, blockchain technology was found suitable for solving many real life problems like e-governance, e-commerce, that asset transfer, IoT security, many things. Uh, but here, when I search, I find there is a lot of difference in the market price, because Ethereum, even though it's supporting application development, but it has its own native currency also, and that native currency called Ether. So that Ether amount is very low, but still it's second popular blockchain platform in the market, second popular. So even though price is quite high differences there, but why Ethereum is so popular? Okay, so if I talk about Bitcoin you can just think as like old days calculator that can calculate only some numerical operations. Similarly, Bitcoin has the Bitcoin scripting language that will help someone to check the validity of the transaction, nothing else. So that scripting language is not Turing complete. So therefore you cannot treat it as like C or Java, C++. No, you cannot develop application. It doesn't support so many features. So therefore, do you know who is this person?
Alan Turing.
Yes. So Alan Turing is not happy with this language because it is not Turing complete. This language cannot solve. I think there is some echo. If you can mute your. Yes. Hello. Yeah, there is some echo. Can you please
What is his
mute?
role, sir? Sir, what is his role in this? Alan Turing.
Sorry.
May I understand what is the Alan Turing role?
Right. Yes, Alan Turing, the Turing machine. The Turing machine.
Yeah.
Yes. So the Turing machine can solve all the solvable problems, right? Whatever problems are solvable, Turing machine can solve them. But here, this language cannot solve some of the problems that Turing machine can solve.
Okay.
This language cannot solve some problems that Turing machine can solve, because this language does not support different features like recursion, looping, all these things. Wherever, if I look at C++, Java, they are Turing complete. It means that whatever Turing machine can do, this language can also solve those kind of problems, all the solvable problems, because they support recursion, iteration, all these things. That's why Bitcoin scripting language is not expressive enough to solve all these Turing solvable problems. Is it clear?
Yes.
Okay. So therefore, we need some other kind of language that is expressive enough. I am getting some kind of echo. Can you please mute your mic? Yes, now perfect. Thank you. So now, therefore, we have to move towards another kind of system which supports another programming language, not only Bitcoin scripting. Bitcoin scripting is very less expressive. Some other programming language that is expressive enough and that is powerful enough to solve any kind of Turing, solvable problems. So therefore, we can think Ethereum as like smartphone. If I consider that Bitcoin is like old calculator, Ethereum is like our smartphone that has also calculator as one application. But beyond this, beside this one, in addition, it supports other applications as well, right? So this is more powerful. I mean, in Ethereum, what happens? This he is actually, when he introduced this, he was just 19 years old, very a student, and now he is famous, world famous. Okay, so Vitalik introduced this Ethereum with the support of one Turing complete programming language, And the programming language is Solidity language. There are some other languages also, like Python specific. So that is the Viper. Viper was another language. LLP was another language that also Ethereum supports. But Solidity is very popular programming language. And because of this programming language, what you can do, you can write small programs, and you can put all those programs in the blockchain, and the blockchain copy will be with every person, right? So if I store some program in the blockchain and the blockchain copy will be with everyone, so everyone can execute that program in a decentralized manner. Decentralized manner. That's why this blockchain is going to help you to develop application, decentralized application in a trustful manner. And those kind of small program that you can write in this program in a programming language is called smart contract in the context of blockchain. So smart contract is a computer program that can be executed in a secure environment, blockchain, and that will deal with digital assets. And this is the program. High level is very similar to JavaScript programming language. If you compile it, you will get some kind of bytecode. Bytecode is intermediate code that you already know, and this bytecode you have to store in the blockchain. You have to deploy in the blockchain. Okay, so if you deassemble 660 is nothing but the code for mnemonic push. So anyway, so you can get this kind of in the mnemonic form, that you can understand that some opcode is there, some operands are there. So this way it will work. And this program will be this one will be in the blockchain, and you can execute this one on your own machine, right? Because the blockchain copy will be with you. Your node is acting as your machine acting as a node in the Ethereum network. This code is there in the Ethereum blockchain, so you can execute this program using Ethereum virtual machine that I talked about. Virtual machine will help you to execute this one. And like you, everyone in the network can also execute the same program on their own machine. And this way, some decentralized execution of the application can happen. And so that's why it's called decentralized application. So here, this is the blockchain. Suppose this is one block. In the block, you will have some, you can store here the smart contract code. And in the blockchain, even in the blockchain, you will have some storage. You have to assign some storage for execution of this code, because in code, if you look at Java code, for example, there is some member variable, there is some functions, and functions operating on member variables, right? So those member variables will be stored here permanently in the blockchain. Okay, and so anyone in the network can request that I want to execute this code, so the code can be executed and the storage can be updated. In the form of transaction, you can say that I want to execute this function of this smart contract code. So one example is that how this smart contract code will help significantly, drastically change our whatever we feel. For example, currently we are using Amazon. How Amazon works? Amazon is centralized authority. Because Amazon is a very popular company, that's why we trust Amazon, right? But suppose you want to introduce your own e-commerce platform. Do you think that other people will use your e-commerce platform? I want to, get your answer. That suppose suddenly you have created one e-commerce platform. Do you think that other people will use it?
Yes, sir, but it depends upon its purpose, right?
But do I really trust your platform? How the transaction happening, all these things? Any dishonest, you might be honest person. I don't know you. You might be honest person, but someone can be dishonest and someone can create this kind of platform to take money from the fraud, right? Fraud case can happen. So therefore, because of this centralized authority, if Amazon is very big company, that's why we trust. But if any common person will introduce this kind of, it will take a lot of time, even he can fail.
It take a lot of time to
Right.
gain the trust.
Right. It depends. If he is lucky enough, then of course. If he is not lucky enough, maybe because of this centralized thing. But anyway, how blockchain is going to help in this case? Suppose what I do in the blockchain, I am the seller and you are the buyer. I am acting as a node, you are acting as a node. And in the blockchain, this program is being written and it is in the blockchain, right? So this is the smart contract. And this smart contract, the functions, all these things, doing similar thing as Amazon is doing. So now what will happen? So first, buyer wants to buy something, right? So buyer will send a request that I want to purchase these things. Then that information will be sent to the seller. Seller will, notified to the seller. Seller will tell the, so one, okay. Seller can tell the amount, okay, this is the amount. Then buyer will be notified by the amount. Those can happen. And then buyer can send the amount that, okay, pay the money. Buyer can pay the money. So when buyer will pay the money, that money will be with smart contract. It will not be given to the seller. So smart contract can hold cryptocurrency. So when buyer will send cryptocurrency, that cryptocurrency will be with the smart contract. And that will be notified to the seller that yes, buyer has paid and the payment is with me. Smart contract. So when buyer will see that okay, payment is with smart contract, seller will process the item and ship the item. When buyer will get the item, buyer will inform the smart contract that yes, I have received the item. Then the smart contract release the money to the seller. So similar thing Amazon is doing, right? But in addition, what Amazon is doing, Amazon also taking huge charge from the seller. It's a business. But if I can consider blockchain network and I put the smart contract, I implement all the functions in this manner. So you can find there is no centralized authority. Only the code is doing all the activities. And there is no chance that Amazon will betray with you. Whatever money you are sending before getting the product, that money will be smart contract, will be with smart contract. So smart contract is completely visible to everyone, and smart contract money. So people can trust the smart contract, right? I can trust the code because code is perfect code is there. And it is with my blockchain copy, your blockchain copy, the code is everywhere. So this execution can happen this way, and all 1, 2, 3, 4, 5, whatever you can see it. These are nothing but the transactions, and these transactions will be placed in the blockchain along with the code execution. Okay, I hope I'm able to convey how smart contract can replace all these untrusted third parties, right? So similarly, you can ignore, you can remove the insurance company and you can put smart contract, and smart contract can do everything. You can, for example, here, instead of putting taxi driver out of a job, blockchain can put Uber out of a job and lets taxi drivers work with the customer directly. So you can see this is the blockchain. These are the smart contracts. So rider can call the corresponding function of the smart contract saying that I want to go from this place to this place and this type of car I want and this number of people I have. Number of seats I require. The information immediately will be stored in the blockchain, will be sent to another smart contract. Smart contract can also talk to each other. The smart contract will assign the corresponding driver. Will send the notification to the driver, and driver will accept the information from this, and then driver will perform all the duties, and finally all the payment can be done automatically through the smart contract. So rider can send money to the smart contract, and once riding is complete, smart contract can release money to the driver. And rating can also be given. All the rating can also be given here. Even as I already told that that dead animal that people have eaten meat from dead animals, and there is no way to check it that whether those meats coming from the original source or not. So therefore, in case of supply chain, what can happen that you have supply, you are supplying something, raw materials, manufacturer is producing the product, and they are transporting all these things to the wholesaler, from wholesaler to retailer, and finally consumer getting it, right? So in the whole process, they all are part of the blockchain. So blockchain is nothing but peer-to-peer network of nodes. So they all will act as the nodes, and there will be some kind of smart contracts, many smart contracts involved to perform all this task. So here you can find whatever operations physically will happen. So every details you can call the corresponding smart contract function. You can put those information in the smart contract. So finally consumer can call the function of the smart contract asking that I want to see from where exactly this product has been manufactured. So the smart contract, since in all the details are already in the smart contract, so smart contract can automatically can give that whole details that okay, this product supplied by these suppliers, manufactured by this company, and then transported by this and even during transportation, whether the temperature, all these things maintained or not, everything can be everything can be stored in the blockchain, in the smart contract, and consumer can get to know. Wholesaler, how many wholesalers was involved, who was the retailer. So every details the consumer can. So consumer can verify if whatever he is purchasing, is it the right product or not. So therefore, finally, I have 10 minutes more. So finally, you can find that this is the layered architecture, that at low level, you have data layer of where your actual blockchain copy will be there. On top of that, you have the peer-to-peer network where all the participants will be connected with each other. On top of that, you have the consensus layer. As I told, Bitcoin uses proof of work. On top of that, you have incentive layer where you can get some kind of reward if you work honestly in the network, if you behave honestly. On top of that, you can have some kind of smart contract code, that automated programs stored in the blockchain. On top of that, you can apply those, you can go for different kind of applications. It can be asset transfer, it can be e-commerce, it can be insurance, whatever. And you can find the growing interest. So number of applications really increasing day by day. If you look at Niti Aayog, if you go here, you can find there is a very nice guidance that in which case, which application you go for blockchain, in which application you do not go for blockchain. As I already told, not only Bitcoin, there are some, not only Ethereum, there are so many different platforms available, and you can also check those, Polygon, Matrix, Cosmos is also going very popular. Hyperledger is already popular. But all this one, they are some blockchain are completely private, some blockchain is public, someone is consortium. So when I talk about Bitcoin or Ethereum, it's completely public because anyone can join anytime, anyone can leave anytime. But if I talk about Hyperledger, it's completely private. This is this blockchain platform designed for enterprise use. So individual organization can have this blockchain based solution. So it's going to be the control will be in one hand. But there could be also consortium. Not only, for example, all IITs can come together and can share their library books, for example, right? In this case, they have to create some kind of consortium blockchain network, so through which they can share their library resources. But at the same time, there is also hybrid kind of blockchain that is just taking the most benefits from a public and private one. Because in case of public, there is some drawbacks. For example, it's public, it's very good. But what is the drawback? Drawback is that very slow. Per second, only 7 transactions in Bitcoin can happen. Very slow because a lot of more people involved in the consensus algorithm. Whereas private, it's more very fast. So hybrids taking based from these two. So in this case, even though something is private, maybe mining can be done private, but verification can be done by publicly. Okay, those kind of something is mining, some activities can be private, but some activities like verification can be done publicly. For example, that happens in case of voting system, that something happens very privately, but something can be verified by everyone. At the same time, whether we go for giving permission or not permission, that also depends. So in case of public, of course, we have to go for permissionless or permission. Public can be also permissioned, huh? Or permissionless. I mean, if you want to join, you may not require any kind of permission like Bitcoin. But maybe there can be some public network where you need permission to join, for example. It may happen. Uh, but whereas if I look at private or consortium, they are going to be permissioned only. Okay. Okay. So now, again, this one I get from this source that it's saying very nicely that when to go for public permissionless blockchain, when to go for public permission blockchain. For example, here you can find why we need permission, because something is going to be in a private manner, but all public should verify those things, right? So in this case, you might require some kind of it's going to be publicly verifiable, but you may require some kind of permission before joining. For example, in case of government, suppose all all citizens can join without, but maybe you need some permission to participate in some getting some kind of services, maybe. Okay, so these are the characteristics that you decentralization. Once you write something, that will remain permanently, persistency. No actual identity will not be really revealed, and you can trace everything. You can verify everything. Transparent. As blockchain, when Bitcoin started, it was blockchain 1.0, but then smart contract introduced, then decentralized applications developed. I mean, network of blockchain also considered, and also industry level adoption is also happening today. So we are moving towards. Of course, there are certain challenges. People are working on that. Interoperability, if we have different kinds of networks, can different networks talk to each other? Scalability, security, privacy, throughput, how many transactions going to be considered per second throughput? So that's quite important factor also at this point. Today also we are moving towards metaverse, that you already know that Facebook already created, moving towards this direction, and they have changed their name to Meta. So very interestingly, I want to show you this thing. So you can find this is a metaverse, digital avatar, digital world where you can purchase land, digital land. You can play games. You can interact with your friends. So you can transfer something, some assets. You can create one. Maybe you can paint something, and you can sell that paint to many people. So yeah, non-fungible tokens. Okay, NFT. You can create so many. You can transact through cryptocurrencies. So in metaverse, of course, there is a big role of blockchain that is coming to that must come in future. So that's why that blockchain has proven to be useful technology for 6 key metaverse areas like proof of ownership, identity proof, transfer of value, governance, interoperability, accessibility, all these things. Those are very crucial things that are going to happen. Okay, and then the last thing that I want to show you one video that can help you to understand that how supply chain works in this case. So I hope that the video is, I don't know whether you can get the sound or not, but there is some caption. You can just, so is it visible to all of you?
Yes, sir.
Okay, okay. So let me play this one. If you do not get sound, so caption is there, you can just. Babies have died after drinking milk contaminated with melamine. Fears are growing around the world over the safety of Chinese milk products.
小伙子，我想来一条这个鱼。QR code on the fish. And when I scan the QR code, it gets me to the detail information page.
Okay, so therefore you can find that you can deploy IoT devices to capture all this information automatically to store in the blockchain automatically that will interact with smart contracts. And so this technology is really useful, that what we are expecting for. And when we are talking about smart life, smart city, so you can understand that without blockchain our life cannot be smart. Okay, so with this, I would like to conclude my talk. So I'll be happy to accept questions from all of you.
Any questions from participants? Thank you so much, sir, for the
Thank you.
we came to understand the significance of trust, transparency, as well as the decentralization on system, and with the real case examples also, especially the Bitcoin transaction structure as well as the script execution. We came to understand the importance in the logical components. And thank you, sir. Thank you very much for the presentation.
Okay,
Thank you, sir. Thank you,
Thank you
sir.
once again.
Thank you, sir, for your wonderful talk. Thank you so much for your.
Thank you your invitation as well. Thank you all participants. Thank you. Bye.
Thank you, sir.
Thank you, sir.
The participants are requested to fill the feedback form for this session as well as the attendance form for this session. And the next section will start by 2:30 p.m.
You can leave the session. You can join at 2:30.